Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about interrupt priorities. See, we know that whenever there is an interrupt occurred, that interrupt service routine will be executed. But if you think of the condition, if multiple interrupt occurs at the same time, what to do? So we know that which interrupt should be given importance, but microcontroller don't know. So that's why we go with the priorities. So we given high priority for an important task. So that's why we are going to perform this priorities for this. So we can group at two groups, one group for a low priority group and then another group for a high priority groups. So when two interrupt sources are occur at the same time, so the microcontroller decides which interrupt should be serviced based on the priorities. So again we have another question. So we have only two groups. One is a high priority group and another one is a low priority groups. So you may think that there is an interrupt, two interrupts occurred at the same group. For example, it is a high priority group. There is a two or three interrupts available. If two interrupts occurred at the same time in the same group, what happens? Again, there we use this default priority orders. So default priority order means we already fixed that interrupt priorities. So based on that group, we can try to modify that. Look at this. So we have an interrupt priority register. So we can 8-bit register. We can set it as a 1 or 0. So if it is a 1, it comes in high priority group. If it is a 0, it becomes a low priority groups. Inside this default priority group, so this is the actual order. Look at this. This is an external interrupt 0 and this is the timer 0 and then external interrupt 1 and then timer 1 and then serial. So this is the default priority orders. So here without group, so this is the actual order. So if you set in 1 and zeros, so based on that, that interrupts will be occurred. For example, default this external interrupt 0 is in high priority. Next will be a timer 0 and then next will be external interrupt 1 and then timer 1 and then serial. So serial interrupt is a lowest priority in the group. For example, I am going to group it to the two groups. So for example, look at this. I am taking a serial interrupt as an high priority group, remaining 4 as an low priority groups. What happens? It need to give an highest high priority. So what happens? The serial interrupt becomes the highest priority. After that, external interrupt 0, then timer 0, then external interrupt 1 and then timer 1. Because so in high priority group, only one interrupt is available, that is a serial interrupt. So this is the highest priority. After that, so we need to go for a low priority group. So low priority have 4 interrupts. There is an external interrupt 0, timer 0, external 1 and timer 1. So what we do, it again uses the default priority orders. So default priority order is same this. So external 0, timer 0, external 1 and timer 1. So this will be followed. For example, we can see it's another example. For example, serial interrupt and timer 1, I am going to group it in a high priority group and these remaining 3 will be grouped into the low priority groups. What happens? So here most highest priority will be, we need to give a high priority group. So high priority group we have 2 interrupts. One is a timer 1 and another one is a serial interrupt. So once if we go within that group, again it uses the default order. In default order, timer 1 is a high priority compared to serial. So what happens? Highest priority becomes a timer 1. So next priority is serial because these two only available in a high priority group. After that we go for a low priority group. Low priority again we have a 3 interrupts. There is an external interrupt 0, timer 0 and external interrupt 1. Again here it uses a same default priority order. So after this, first highest priority is timer 1, second will be serial, next will be external interrupt 0, next will be timer 0, next will be interrupt 1 becomes. So based on our request, we can form an priority orders. So just we can change it, it is to be a low priority group or a high priority groups. So once if it becomes a high priority or a low priority, within that group we have any number of interrupts. So within that group, it uses the default priority orders. Look at this interrupt SFR. Look at this. This is for an enabling this interrupt enabled register. This is an overall enabled. This is an EA. this is reserved, or this will be used only for an higher, that is a next version, that is a timer 2. Look at this, this is a timer 2. So these two bits we are not going to use in 8051. Look at this, this is an enable of serial port interrupt, this is an enable for timer 1, this is an enable for external 1, this is enable for timer 0, this is enable for external 0 interrupt. So overall enable must be 1, this is the global interrupt enable must be 1 to overall enable it. After that, again individual interrupt will be enabled only with that corresponding one. So EA must be 1. After that, wherever it wants, that interrupt will be enabled. For example, EA is 1 and EX0 is 1 means, so that external interrupt 0 is enabled. For example, these two will be 1 and EA is 1 means, the timer 0 and external interrupt 0 will be enabled. For example, if EA is 0, even though all the bits are 1, all the interrupts are disabled because globally it will be disabled. Thank you.